we have a not too bad initial value problem here to evaluate using the Laplace transform method. The Laplace transform is a beautiful method for evaluating initial value problems because it doesn't require us to first obtain a general solution. We have a specific solution right out the bat or the gate, right off the bat, whatever. So how we're going to address this is we're going to take the Laplace transform of both sides of the equation in order to find some value for the Laplace transform of x of t. Then we'll find the Laplace inverse of that to give us x of t. So let's begin. It's stated that 3x dot is equal to negative x of t plus 9u of t, where x of 0 is equal to 0. All right, let's note that x dot is the same thing as x prime, which is the same thing as d by dx, which is the same thing as big D of x, which is the same thing as however you note the derivative of x. Let's also note that the Laplace transform of the derivative, let's call this f prime of x, is equal to s times the Laplace transform of f of x, which is cap f of s, minus small f of 0. You can see how the initial value stuff comes in here. So finding then the Laplace transform of 3x dot, because the Laplace transform is linear, it's an integration, we can pull this constant term out, which leaves us with 3 large bracket s cap x of s minus x of 0. We were told the value of x of 0 to be 0, so we can just do that. So rewriting this, we'll have 3s x of s being equal to the Laplace transform of this side. Now again, because the Laplace transform is an integration, we can just take each of these individually. The Laplace transform of negative x of t, of course, being negative cap x of s, plus the Laplace transform of 9u of t, where u of t is our unit step function, otherwise known as our Heaviside function. And of course, we know that it looks like this, where we have 0 there, and then it extends like that. I should probably derive the Laplace transform of this function in another video, but for now, we'll just know that the Laplace transform of this unit step function, that is a t, is equal to 1 over s. Therefore, we can make this equal to 9 over s. Now let's group all of our x of s terms on one side. So this will give us 3s x of s plus x of s, adding it to both sides, is equal to 9 over s. Pulling out the x of s from this, we get 3s plus 1 x of s being equal to 9 over s. Beautiful. X of s is then equal to 9 over s, 3s plus 1. Whew, not too bad. But we were not tasked with finding the Laplace transform x of s. We were asked to find the time domain function x of t. Now, there are two ways we can go backwards from here in order to get the Laplace inverse of x of s. We could use a very complicated integration, or we could try to use our Laplace transform table, or look for some pattern here that leads us to a Laplace transform pair that we know. Looking at this isn't quite giving us what we want, as we have something of a quadratic in terms of s in the denominator. What we can attempt to do is to separate these two terms into two individual fractions, which will give us something looking a little bit more like what we're looking for. And how we'll do this is with a technique called partial fractions expansion. And it goes a little something like this. Let's move the 9 to the side for the time being, right? So we'd have this as 9 times 1 over s 3s plus 1. Let me rewrite that. Some people don't remove the numerator, or they don't put it in terms of 1. I just find it to be a little bit easier this way. And we'll say the following. We'll say that this fraction, 1 over s times 3s plus 1, we'll assume that we can write it in such way: a over s plus b over 3s plus 1. Whatever it is that a and b are, right? So let's go in and multiply both sides by s, 3s plus 1. That will give us 1 is equal to 3s plus 1a, as the s from here kills the s from here, plus sb, as the 3s plus 1 here kills this 3s plus 1 here. Great. So finding some value of s, well, b is the more obvious one, that drives the term to 0. We'll say let s equal 0 for argument's sake. That will give us 1 is equal to 3 times 0 plus 1a plus 0b. This, of course, goes immediately to 0, as does that, which gives us that a is equal to 1. Great. Lovely. So finding some other value of s, which we can see here, would be negative 1/3 to drive the a term to 0. We have 1 is equal to 3 times negative 1/3 plus 1a. Of course, all of that goes to 0, plus negative 1/3 b. All right. Multiplying both sides by negative 3 leads us to believe that b is equal to minus 3. Cool. So we can rewrite this and we can say that we're trying to find the Laplace inverse now of 9 times 1 over s plus negative 3 over s plus 3. I'm sorry, negative 3 over 3s plus 1. My bad. All right, so this is now immediately looking a lot more like something we might have seen at some point, right? Lovely. So let's start on this side. Of course, we know that the Laplace inverse of 1 over s is just going to equal to u of t. So we have that part done. Now on to this part. What does this look like? This would almost resemble the Laplace transform pair that tells us that the Laplace transform of e to the minus bt is equal to 1 over s plus b. Almost, right? Almost. So let's see what is needed for it to look like that entirely? Well, this 3 here and this 3 here are kind of just hanging around, right? So what we're going to do is that we're going to, for lack of a better term, cancel it, right? So what we're going to end up with here is, let's move the negative sign out. We're going to end up with minus 1 over s plus a third. Note that those are both the same fraction, right? So this is looking a little bit like this, right? So what we'd end up with this being, of course, again, because the Laplace transform is just an integration, we're free to move this negative sign out. This would lead us to the Laplace, or negative the Laplace transform of 1 over s plus a third being equal to negative e to the minus a third t. So our final answer here would be 9, let's say x of t, x of t is equal to 9 u of t minus now 9e to the minus t over 3. Or if we prefer to pull the 9 back to the outside, it would be 9 u of t minus e to the minus t over 3. And that is it. Hopefully, this was not too rigorous. This was actually a more straightforward one, but these do take a bit of practice to be able to recognize the Laplace transform pairs and hopefully put them together, or be able to actually take them apart in a partial fractions expansion and solve them piece by piece to get what we wanted. I will be following this video up at some point, probably in the next upload, with a few of these first principle transforms. For example, the transform of the unit step function, probably even the transform of the derivative, and more than likely some further worked examples of initial value problems, as these again are not too rigorous but can be a bit tricky to get, especially at first. Thank you.